Okay, so in this video, I wanted to review factoring, but the factoring problems are going to be a little more complicated. And the main reason for the complicated stuff is that now we're going to be factoring terms that say stuff like 5x squared instead of just x squared, which makes it trickier to do. So there are going to be two methods that we're going to use in class pretty frequently for this. One of them is called just guess and check, and the other is factor by grouping, which this method too is also, I've seen it called splitting the middle. So I'll put that here too, splitting the middle term. So we'll talk about that one in a minute. So method one, educated guess and check, we're going to factor this guy two different ways. So educated guess and check, well, if you think it factors, then make your two sets of parentheses, right? And the idea is that if I FOILed out the stuff that was inside those parentheses, I would get this back. So two terms that are going to multiply out to 5x squared would be 5x and x. And that's not too hard because 5x and x are the only nice terms that work. Like, you're never going to really do 10x and half x. Otherwise, it probably wouldn't be a problem where I ask you to factor by hand. If it was something like 6x squared, then you'd have multiple options because this might be 6x and x or 3x and 2x, and then it gets a little bit trickier if you have multiple options. But in this case, 5x and x are our only choices. I need to get it to the constant terms out here to multiply to positive 6. And so my choices here would be like 1 and 6, or 2 and 3, or 3 and 2, or 6 and 1, and all the negative versions of these guys also. So if you start playing around, really you're just trial and error guessing and checking here. So if I tried something like, I don't know, let's try like 1 and 6, and if I just did plus and plus, well then the issue here is when I FOIL this out, I would get the 5x squared, which I want. Down at the end, I'd get the 6, which is what I want. But in the middle, I'd end up with plus 30x plus 1x, which is not going to give me the negative 17x I'm looking for. So 1 and 6, positive 1 and positive 6 are out. And if I did negative and negative, I still get the plus 6. But in the middle, I'd end up with negative 31x here, right there. So instead, you just kind of play around with your choices until you find what works. And it turns out the one that's going to work is if I put a 2 here and a 3 there. So negative 2 and negative 3, because then if I were to check it, I would get 5x squared for the first terms, negative 15x for the outer terms, negative 2x for the inner terms, and positive 6 for the last term. So then this would turn back into 5x squared minus 17x plus 6. Which is what I want. So this is the factoring that I'm going for. Hold on one second. Okay, so the next way that I want to do this, method 2, guess and check is great if you're good at it, but if you're not good at it, it's really not the greatest thing to have to do. So the second way is called splitting the middle term or factoring by grouping. And this is one that a lot of students have seen little bits and pieces of it. The most common way I've seen it done is people make a little x, and then the idea is that you always want to put that you're looking for numbers that multiply to, and then you actually figure out what a times c is here, a times c, and you always want it to add to whatever b is, and in this case b is going to be negative 17. So in our example, I'm looking for two numbers that multiply to a times c, which is way up here, it's 5 times 6, so 30. And I want it to add to negative 17. I want those two numbers to add up to negative 17. And the idea is that you put your two numbers here and here. So two numbers that actually work, and this is the puzzle that you have to solve. And in this case, you'll eventually get to, well, negative 15 and negative 2. If I multiply those guys together, I get 30. And if I add them, I get negative 17. So that's great. So then what I'm going to do is I'm going to rewrite the original one right here. And what happens is you actually keep the first term and the last term the same. So in my new step, I'm going to write the first term the same. I'm going to write the last term the same. But the splitting the middle is where you actually do something here. So I'm going to split this term up into two other ones. And I'm going to get minus 15x and minus 2x. Hi. Give me 1 second. Yeah. Okay, all right, thanks. Okay, so sorry about that. Okay, so that's where this 15 and 2 come into play, is it should always end up splitting that middle term up. And then the nice thing is when I split this up, I can look at these two terms and these two terms separately. So think of it like there's a little plus in between here, because a lot of students end up leaving that out. So what I can do with the first two terms is I can factor out a 5x, and I get x minus 3 left over. And then I've got plus, and then if I look at the last two terms, the goal is to get another x minus 3 here. And the way that I do that is by factoring out a negative 2. So then there's one last step here, and that's finishing this off. Well, I've got 5x, x minus 3's. And then I take away 2 x minus 3's. So what I really have is 5x, and I took away 2 x minus 3's. So here's my factorization of the original problem. And if you look at what we got, it's the same exact thing. Okay? Now let's say that you made your little chart, multiplies to 30, adds to negative 17, and you ended up putting the negative 2 here and the negative 15 there. That's actually okay. It doesn't actually change your final answer. It changes the work a little bit. So let me rewrite this. The first term and the last term stayed the same. So this is still 5x squared, and this is still 6. And then now on the inside, we've got the splitting the middle term turns into minus 2x and minus 15x, and then plus 6 there. Okay, so if I treat the first two terms by themselves, now the only thing I can factor out is the x. So I get 5x minus 2. And then my goal is to get a 5x minus 2 out of this one also. And so what I can factor out of that is a minus 3. And so now if I look at it, well, I've got x, 5x minus 2's, and then I take away 3, 5x minus 2's. So in all, I've got x minus 3 of 5x minus 2's. So I get the same answer, it's just that they're in switched order now. But that's okay, because I'm multiplying, and it doesn't matter what order you multiply in. A times b is the same as b times a. Okay, so now let's take a look at number 2. And I know it says do it 2 different ways. I'm just going to say do it by splitting the middle. That's the method that I want to practice, because guess and check, if it works for you, great. If it doesn't work for you, then this is the method you can use. So for this one, remember, it needs to multiply to a times c. So we needed to multiply to 3 times negative 7, so negative 21. And then it has to add to b. So b is 20. So if you think about, well, what multiplies to negative 21 but adds to 20? Well, if I use positive 21 and negative 1, that works. And that's the one puzzle that you have to sort out. So then I'm going to rewrite my original, 3x squared plus 20x minus 7. And then I'm going to rewrite the first term, because that stays the same. I'm going to rewrite the last term, because that stays the same. And then I'm going to split up my middle term into a positive 21x and a negative 1x. So here's what that turned into, this new line here. And then I start to factor each part by itself. So the first part is going to be, I can factor out a 3x from both terms, and I get x plus 7. And then I need an x plus 7 over here also, otherwise I haven't split the term properly. And the thing that I can factor out of this one is a negative 1. So really what I have is, I've got 3x, and I take away 1 of x minus 7's. I've got 3x, x plus 7's there, and I take away 1, x plus 7. So I've got a total of 3x, take away 1, x plus 7's. And there is my factored form. Okay? So I want to do one more example, number 3 here. By the way, you can always check these just by foiling this out and making sure you get the original back. So don't ever hesitate to do that if you're not sure. So number 3 is solve this equation. And when you have standard form, a lot of times it's useful to factor it. And then whatever this is, a times b equals 0, either a is 0 or b is 0, or they're both 0. So then you set each one equal to 0 and you solve them. So in this case, well, we've got this ugly thing here, and maybe you can factor it by hand, but if you can't, go to this method. So it's got to multiply to a times c, which is 7 times negative 3, negative 21. And then it's got to add to b, which is negative 20. So the numbers that are going to work there, well, multiply to negative 21, but add to negative 20. Well, let's try negative 21 and positive 1. Those work. Okay, so if I rewrite the original, that equals 0. And then this left side of the equation, I can rewrite the first term. I can split the middle term into minus 21x plus 1x. And then I can write the last term, which stays the same. So now it's, okay, let's deal with these two terms by themselves. So if I factor out a 7x from the first one, I get x minus 3. And then plus, and I need an x minus 3 here. Well, how many of them do I have? I just have one of them sitting there. So it's like factoring out a 1 equals 0. So I've got 7x plus 1 times x minus 3. That's how many x minus 3s I have. I have 7x of them and one more. So that equals 0. And then remember now, I've got two things multiplied together equals 0, so at least one of them's got to be 0. So if I do 7x plus 1 equals 0, then I get 7x equals negative 1, so x is negative 1/7. And I've got x minus 3 could be 0, so I should have said or there. So then x would end up being 3. So here are my two answers. And you could write it, if you like this notation, it's the set negative 1/7 and 3 as my options. So these are the values that x could be. Okay, so I'm going to stop there. Hopefully that helps kind of review a little bit and it makes sense. And if you have any questions, either shoot me an email or come talk to me during office hours. Okay, thanks. Bye-bye.